All right, so we're going live then.
Okay. Share.
So I'll introduce you on. A good afternoon, everyone. Welcome to the webinar for AI Texas Group. My name is Sid Gupta. I run a tech company here in Texas called Nesh, and welcome everybody. So the reason we are having this webinar today is because when I asked you all what you were interested in learning about in the space of AI, one of the things that kind of came up was around natural language processing and how can businesses use that. So I'm kind of very excited to welcome our guest today. I'm going to introduce her, Dr. Huan Sun. She's an assistant professor in the computer science department at Ohio State University. She was a visiting scientist at the University of Washington, and she received her PhD in computer science from UC Santa Barbara. And she has a bachelor's from University of Science and Technology in China. Her research interests are in natural language processing and AI, with an emphasis on building natural language interfaces that can help people complete tasks through dialogues. She has received a lot of awards over her career. I'm going to list a few: NSF Career Award, Google Faculty Award, and OSU Lumley Research Award. So welcome, Dr. Han. Thank you so much for joining us today. I'll hand it over to you. I'll turn off my video, and then we'll kind of go back to questions towards the end. And for everybody watching the webinar today, please feel free to ask your questions in the chat. We'll kind of get to it towards the end of the talk. But welcome everybody. Thank you, Dr. Han. Over to you.
Thank you very much, Sid, for the invitation and for the introduction. Hi, everybody. Thank you for being here. It's my great pleasure to talk to you on natural language interfaces, especially on natural language interfaces to relational databases today. I'm also going to review the history a little bit, and hopefully it will give us a more global picture and remind us of where we were and how we got where we are today, and shed some light on how to proceed. If you have any questions, please don't hesitate to ask, or feel free to reach out later. Okay. Natural language interface is an interface that allows the user to interact with the computer system using natural language. So why do we want to build natural language interfaces at all? The answers to this question are not really the same over the time. Okay, let's travel a little back to in time to 1950s. We can see that back then computers were very hard to use, and only expert users were able to operate them. In fact, not just the computer systems, so were household appliances back in 2000s. Here's a funny quote I copied from one of the earlier papers on natural language interface to household appliances. So starting from the late 1960s, people have been developing natural language interfaces. So why do we still need to do it now? Nowadays, of course, we are lucky that computers and household appliances are much easier to use. However, we are still in need NLIs to easily access and query big amount of data, to command a network APIs and smart devices, and also interestingly, to assist computer programming and make programming easier and more efficient. Under these motivations, there have been various kinds of NLIs, such as those to unstructured text data, to semi-structured tables, to structured knowledge graphs, relational databases, APIs, and code snippets. And these NLIs are often called different names by different subcommunities. For example, those to text, to tables, or to knowledge graphs are often referred to as question answering. And those to knowledge graphs, relational databases, and APIs are often called semantic parsing, which means to translate a natural language question to a formal meaning representation or a logical form. And those two relational databases, APIs, and code snippets are often referred to as program synthesis, where the output is a program, being a SQL query or a general purpose code like Python. If we further extend the natural language interface to multi-turn, we can actually arrive at the so-called task-oriented dialogue systems, which can be interactive and conversational to assist users to complete tasks through dialogue. Before I dive deeper into NLIs, let me step back a little and clarify something. If you are not from the NLP field, say you work on visualization or HCI, you might argue on whether natural language is the only or best medium, or even a good medium. Well, as much as I love this NLI field, I don't think it should be the only or it can be the best on its own. I really think we should combine different types of interfaces, including those graphical user interfaces or demonstration by example, like query by example, program by example, because they have their pros and cons, and we should embrace this multimodality. However, in this talk, I'm not gonna talk more about multimodality, but we'll focus on natural language interfaces. You might also wonder why we pick the formulation of NLI to X. Like, like text, tables, knowledge graphs are of quite different nature. And would it be too general to be useful and meaningful? Well, my take on this is in the era of deep learning, with all the data represented as some kind of vectors, these different types of NLI problems can be formulated in a very similar way, like in the encoder-decoder paradigm or in the pre-training fine-tuning paradigm. So developments in one type of NLIs can actually inspire another. In fact, in my own research, we got inspired constantly in this way. So today, I'm going to focus on NLI to databases. We are also actively working on other types of NLIs. But today I won't have time to cover each of them, but we'll focus on the relational databases, and which is sometimes called semantic parsing. If you have other questions or want to discuss other types, so feel free to reach out. I'm happy to discuss offline or in other occasions. So I'm going to review the history a little bit, because as I hinted earlier, NLI has got a long history, which makes me very curious about what happened in the past and how we got where we are today, and what were the challenges in the past and how we are doing them better. So in the next few slides, we are going to review the history a little bit. Now, if we draw a timeline, we can actually find that NLI is not really a very smooth journey. Before mid-1980s, there were a lot of work and research prototypes. And after that, it seems research kind of tapered off until, say, 2005. More recently, we have data sets like WikiSQL and Spider, which have boosted the research a lot. So this makes us very curious about what happened during this period. Okay, let's take a nice review, which was written around 1995, and see what people viewed as challenges at that time. Here is an incomplete list. Okay. First and foremost, and unsurprisingly, natural language understanding was regarded as one of the most important challenges at that time. And the paper listed several examples here. For example, the example here shows that basically a parser needs to know that with a driving license is to modify the employees rather than modify the company. However, interestingly, if you try one of the online parsing demos on these examples, you'll find that they still make mistakes in them. That means that although over the years we have made tremendous progress in natural language understanding, it is still an important one in the current days. Portability is another challenge at that time, which means an NLI that was built on a particular database or a particular application could not be used for others, especially on databases with very different schema or on different topics, or even with different languages like English, French, things like that. And if we think of NLIs as intelligent agents, there will be more interesting challenges, such as how should the agent reason about the user, reason about the world? How should it model the current state of discourse? How can it generate natural responses to the user? And so on and so forth. Actually, all these things are still actively being studied in the NLP field. You see, interestingly, what people viewed as challenges in like 30 years ago are still what we are trying to address today. So how are things different? Of course, we have larger scale data from the web or from in-house, and we have more powerful computing resources. This made it possible to develop more advanced methods. For example, for speech recognition, we probably don't need to type anymore. The speech recognition rate success rate is pretty good, even for speakers like me who have accent. And then for natural language understanding, for underlying data representation, and so on and so forth, we have made a tremendous progress there. However, the challenges mentioned previously are still here, and we are still a bit far from completely solving them. Today, we will focus on the challenge of portability, which I break down to 3 aspects: generalization, adaptation, and interaction. These 3 terms have different meanings under different contexts. And so I'm gonna clarify them a little bit and make it more clear what we mean by them in this talk. So generalization means to build models that can work well, or at least applicable on different databases or data sets. Sometimes we call domains. Adaptation means to further adapt a model that was trained on source domain to work better on target domain, which is actually what we care about. And interaction aims to enable a model to interact with real users and continually learn from the user interaction. In practice, you can think of the process as first building a model that can be applicable on different domains, and then adapt the model to work better on the target domain we care about, and then make the model interact with real users and continually learn from the user interaction. Today, I'm gonna further narrow the focus down to generalization and also briefly talk about interaction. Okay. However, if you want to discuss other aspects or have other questions, feel free to ask. This work was led by my student Xiang Deng during his internship work last summer at MSR, and I was very fortunate to be involved in this project. Let me first clarify what a natural language interface to database means. Sometimes the task is also called text-to-SQL. So the task formulation is like the following. Given a database with a set of tables and column names in each table, we also have the foreign key information as shown as dotted line here. Now the user gives us a query for the cars with 4 cylinders. Which model has the highest horsepower? So the task is concerned with translating this natural language question to a SQL query so that you can see the user doesn't need to know anything about a SQL query, how to write a SQL query. He or she can issue a question in natural language and explore the data. So in this talk, we want to focus on a very practical setting called cross-database text-to-SQL, which means that at the training and the testing time, we'll use different databases, meaning that you can see the database schema pretty different, okay? And this is also very important in real practice because annotating SQL queries for user questions in for each application, for each database is very painful. It requires a lot of time and it requires expertise to do that. So that's why we want to focus on this cross-database setting. And hopefully a SQL parser or a text-to-SQL model that was trained on the training databases could also work well on the testing databases. Okay. So under this setting, there are concrete challenges like the following. Basically, a model needs to understand the unseen DB schema at the testing time. It also needs to recognize references of columns and values in the natural language question and match them together. For example, they need to know the colored tokens here correspond to the columns like this, or cell values in the corresponding columns, right? So this is some concrete challenges for this setting. So under this background, there has been a recent data set called Spider, which has boosted the research a lot. So in Spider, the authors split the data set in training and testing in such a way that there is no overlap in databases. In addition, they also have more complex SQL queries, such as those including keywords like having, group by, and so on and so forth, and so on. On the left side, we can see a leaderboard showing the performance of various kinds of methods developed on this data set, okay? And we can see that it is very actively being studied, like basically the new data art can be obtained almost every month. So if we look closely at this leaderboard, we'll notice that there's a method called RedSQL, which has been widely adopted among the top performing methods. This is even true when last year we did this work, and it was almost dominating the leaderboard. Okay, so we are going to build on top of this approach. Let me just briefly introduce how this method works. Basically, it takes an encoder-decoder model architecture. The decoder will just output a SQL query, and the encoder will take as input a sequence of tokens, including tokens in natural language question and also tokens in table names and column names in the database. Okay, now how to represent those tokens? There can be different methods. More recently, people are trying to use those giant pre-trained language models like BERT to see whether those contextualized representations from those models can actually boost the performance of RedSQL. We will follow this line of research as we will explain later. Okay? But basically, this is currently the evaluation, the state of the art, the scores on this data set. Despite the higher scores, we want to take a closer look at the evaluation and ask ourselves this question. Is the evaluation actually close to real life scenarios? In fact, last year in the ACL conference, this paper was published in the ACL conference, which was a top conference in the NLP field. So they found that there are high exact token matches between the NL query and the SQL query, which means that, for example, for those queries, user queries, okay, there are already exact column names mentioned in those queries, like age, capacity, weight, highlighted here. They are all exact column names in the database. Okay, that means this makes the SQL inference much easier than it is in real life, because many times when you ask a question, you don't know what the DB schema is. You won't directly mention the column names. So if we modify these queries to more challenging questions by keeping the semantic meaning, for example, for the first query, we can simply remove the ordered by age. That part is redundant without changing the semantic information, semantic meaning of the query. For the second query, we can replace with the highest capacity with that can accommodate the most people. The question is still the same question, but it will become more difficult because the exact column name is not directly mentioned in the query. Now, on such queries, the top performing method's performance actually dropped a lot by around 12%. Okay, this challenge we refer to as text table alignment challenge, which means we needed to better align the tokens in the natural language question with the tokens in the database or in the tables. Okay. Now, how do we address this challenge is one thing we want to focus on. Inspired by the recent pre-trained language models, which have achieved a lot of success on various NLP tasks, such as BERT, Roberta here. Okay, we are motivated to study whether we can develop some pre-training methods to capture the text table alignment better. Just a little background on how the pre-trained language model work. Basically, we can find some unsupervised data to sort of design some tasks that can pre-train the model beforehand. And once the model is pre-trained, the representations will be much better. And once they are used in the downstream task, such as text-to-SQL, the downstream task's performance will be significantly boosted. Okay, so this is some brief background on this pre-training and pre-trained language models. So once we are on that train of thoughts, the real question becomes, how do we collect self-supervision tasks and self-supervision data and design self-supervision tasks for pre-training? Okay. We observe that there are a lot of tables on the web, especially Wikipedia, that have descriptions about the facts in this table. Here shows an example, a table here and a natural language sentence describing a fact in the table. Now we wonder, how can we utilize this kind of data to create some self-supervision for pre-training to learn text table alignment so that the learned representations can actually help the text-to-SQL task later? Okay, so this is the problem here. Lucky for us that we actually already have got a data set, an existing data set called the total, which is a collection of tables and their paired natural language utterances or natural language descriptions. Inside this data set, they also provide human annotations of table cells that already appear in the NL utterance. So for example, the cells highlighted in yellow here are actually mentioned in the NL utterance, like 1995 World Championships. And these two cells are also mentioned as well, although implicitly, like individually or in the relay. So based on such human annotations, we can actually use them to design three objectives, okay, or three tasks. They are column grounding. Basically, it means that we can predict whether each column name is mentioned in the NL utterance or not. And the value grounding means for each token in the NL utterance, whether it is a part of a cell value in the table. And for the task of column value mapping, we aim to find the associated column for each value mentioned in the NL utterance. Okay, so you can see these three tasks are actually very related to the downstream text-to-SQL task because they try to learn or capture the text table alignment. In addition to this setting using human annotations, we also have another setting which we call automatic setting. In this setting, we want to say, what if we don't have human annotations? What if we just have the table and the original natural language description of the table? In fact, we don't need a human effort. We can actually apply exact string match to detect the cell values that are mentioned in the NL description here. And we will show that the performance using this kind of data is actually very close or sometimes even better than the human assisted setting. But anyway, so we can utilize these automatic approaches to have self-supervision and continue to use them for the three mentioned tasks. Okay, so this is the general idea behind the pre-training data and the three pre-training objectives. To summarize, this is our model architecture, where we have the natural language question and the table column names concatenated as input, which we will feed them into a transformer encoder, which is a state-of-the-art encoder model. This model was pre-trained by BERT. We can utilize the BERT parameters to initialize the parameters in the model. After that, we will take the hidden representations of each token and use them to predict the three mentioned tasks earlier. Basically, they are binary classification tasks or some kind multi-label classification tasks. Okay, so under this framework, we can pre-train the model for a few epochs, like 5 epochs. This takes a few hours, but I want to point out that this is already much efficient, much more efficient than many pre-training methods compared in the paper. Once it is trained, we want to say how it performs on more realistic evaluation. As mentioned earlier, we modified the original examples to be more challenging by removing the exact column matches. Okay, so this way we got a new data set. In addition, we also tested on 8 other data sets on various domains like restaurants or flight booking, things like that. Okay. Basically, the idea is we train it on Spider and test it on 8 other data sets to see the cross-database evaluation performance. Here are some results. We can see that using our pre-training method highlighted in the green box here, we can boost the model performance by around 4%. If you are not from the NLP field, you might think 4% is not a huge deal. But for many NLP tasks, improving the performance by 1% or 2% is very difficult. Okay, so this is the general conclusion from this Spider realistic data set. We also have more results on these 8 other data sets. However, I'm not gonna walk you through the details here, but I won't brag about the performance gains brought by our method, but instead I want to actually draw your attention to how low these numbers actually are. Sometimes it's just too low to be useful. And this shows that the generalization challenge, which means the train model on one domain and testing it on other domains or data sets, especially with new insane query structure, SQL query structure, is very difficult. This causes more future work. And also, I want to mention that some data sets like restaurants and Yelp are pretty small, like only 20 or 50 examples there. So this means that we also need larger and quality data sets for more comprehensive evaluation in the future. Okay. So to summarize, in this work, we propose a pre-training methods to boost the text-to-SQL performance under the cross-database setting. And we advocate more realistic evaluation. What I haven't mentioned is that in addition to the above things, we might also want to think about a semantic evaluation metric, which is to evaluate the semantic equivalence between the predicted SQL query and the ground truth SQL query. Right now, we are measuring the exact match between the predicted SQL query and the ground truth SQL query, or the match between their execution results. But a semantic equivalent would be a much better measure to do a fair comparison. And we might also want to explore the potential of different paradigms in addition to pre-training, such as meta-learning, data augmentation, and interactive frameworks for this cross-domain or cross-database settings. I won't be able to talk about other aspects, other paradigms, but let me introduce very briefly about the interactive paradigm. We have been actively studying this line of research. It is led by my PhD student, Ziyu Yao, who just graduated and will join George Mason University as assistant professor. And this line of work is in collaboration with my colleague Yu Su at OSU and Scott in Facebook AI research. So the idea of interactive semantic parsing is as follows. We can think of semantic parsing as a sequential decision-making process. Okay? And we can regard the method to do semantic parsing as an intelligent agent. Basically, during the parsing process, at each step, the agent needs to determine or recognize whether it is certain or not to make a prediction. If it is not certain, then it needs to formulate a question to ask the user to clarify. And the user can provide some feedback. And then the agent can incorporate this feedback to continue the parsing until the end. Moreover, the agent can learn or improve itself by training or updating the parameters using this feedback so that it becomes better and better in the future and reduce clarifying questions to the user. And what I want to stress here is that the feedback is on intermediate parsing steps as opposed to binary feedback on final execution results. This is because the latter case is less practical because in practice, users might not know the final execution results. Otherwise, they wouldn't have asked the question in the first place. Okay. Here is a concrete example. Basically, given this database with only one table for simplicity here, and the user asks a question which tends to be ambiguous because it could mean the number column, or it could mean run by rank the city districts by population. So there's some ambiguity in the question. So the agents gets confused and can't figure out what column to put in the where condition. So it will formulate a natural language question to the user, and the user will give some feedback, and then the agent can continue until it can output a SQL query and execute it and get some results. So this is the whole procedure of the interactive semantic parsing. Okay, we show that with such interactions, basically the framework can improve the parsing accuracy by more than 10% using different base models compared with different base models, with only 1 to 2 questions to the user per user question, meaning that given a user question, basically the agent only needs to ask 1 to 2 clarifying questions to get a 10% accuracy improvement on average. Okay, with that, let me proceed to the conclusion part. To summarize, we've talked about the portability challenge, in which we discussed the generalization and briefly mentioned the interaction. Okay, if we think about NLIs as intelligent agents, there are more interesting intelligent agents. There are more interesting challenges to consider, such as how to reason, how to let the agent reason about the world. A large part of the reasoning will be common sense reasoning, and how to develop a reliable NLI which knows what it can or cannot do. Okay? How to let it interact with the user more naturally and continually learn efficiently from such user feedback. And during the interaction, how to generate faithful, easily understandable responses or questions, and have an engaging dialogue with the user. These are all very interesting challenges to continue to work on. So all in all, while we are getting higher and higher scores on leaderboard on a particular data set every day, perhaps it's also time to zoom out a little bit and keep in mind a bigger picture of what challenges we met in the past and how we are getting better. We might need to build new ties between academia and the industry so as to be aware of real practical challenges. So with that, I hope to conclude the talk and thank you very much again for your attention. And I'm happy to take questions after the talk and also offline, or feel free to reach out. Thank you very much again.
Thank you, Juan. Thanks so much for that talk. That was excellent. I mean, I really liked kind of the breadth of the areas that you covered. I see some questions have come in on the chat too, and I have a couple of questions of my own as you were talking through it. Maybe we can start with one of my questions. I mean, the last piece that you mentioned there was an open challenge, you know, around building common sense into natural language agents. Like, do you have kind of any thoughts around that? How might somebody go about doing that?
Yeah, that's an excellent question. I'll give you an example here. So we are participating in the Alexa taskbot challenge this year. And the task there is to build a taskbot that can help users complete a cooking task or a home improvement task. So you can imagine there, like if a user has a request about how to bake a cake, for example, right? The user might ask questions during the task execution process, and the agent will need to present the recipes and guide the user through doing this task. And during this process, when the user has some special request or doesn't have a certain ingredient or doesn't have a certain tool and asks whether I can replace it with something else. In order to answer such questions and make adjustments in the plan, the agent needs to have some common sense knowledge. So they might know, okay, this food, this ingredient, and that ingredient have a similar flavor, or they can play these tools can serve the same function and things like that. So this is one example of where common sense reasoning can play an important role. So as to how to incorporate that, that's an open research problem. We are still investigating various kinds of approaches. But I think, there are like multiple approaches we can start with, such as incorporate common sense embeddings into the, the dialogue history and things like that to make better predictions.
Got it. Yeah, no, that was great. I mean, I think, yeah, it's an open challenge. I understand how difficult it must be for to kind of make it explain the sense of the world. And common sense is kind of acquired over so much time. I can understand it must be so much hard to kind of do that and train a machine to do that. Another kind of question that I had was when you were talking about that Toto data set that you had that you trained to kind of fix the text table alignment issue that you mentioned. What if someone were trying to do that for a specific domain? Like how might, like, because that's a general table data set that you have, like how can somebody approach that? Is there something that we can borrow from that existing data set? Do we have to come up with something on our own?
That's a fantastic question. So I would start with some existing tables and descriptions from the web or from the Wikipedia. Wikipedia is very comprehensive. You might find a lot of facts on a certain topic like geography or healthcare or bioinformatics and things like that. So I just like to check, the portion of tables and the descriptions on the topic you are interested in, and probably starting from there. Another source you can consider is the sort of the archived articles on a particular domain. So for example, if you are interested in biology, there are so many articles, scientific articles there, right? There are tables in the article, there are table captions describing what this table about. So you might want to check out this those kind of tables and paragraphs describing these tables as well as the table captions. That might be a good start to pre-train a model on a particular domain.
Okay, yeah, that makes sense. Yeah, I guess I just want to switch gears a little bit and then kind of hear more about kind of you, like how did you get interested in the area of NLP? I mean, AI is so broad, NLP itself is quite so broad. Like what interested you to kind of deep dive into this area of research?
Yeah, thank you for asking this. So actually, my journey to NLP wasn't actually a straight path. So I started my PhD study in a related field called data mining, which I think many of you have heard about. So my first project was about biomedical data mining. And I switched the topics for a few times and did another project on topic modeling, which is to infer the topics in a large corpus of documents. And then the real transition point came in 2014 when I did an internship work at the MSR on natural language question answering. Basically, it's similar to what you would say now if you are using Bing or you are using Google, like throw a natural language question there will be a little box showing the precise answer to this question. That was my internship project back then. And that got me quite interested in NLP and especially in natural language interfaces related stuff. Then I guess from that point, I started to do more and more stuff and publish more in the NLP field. So that's kind of my story behind how I got into the NLP field.
Yeah, and I guess it's NLP is so big, you're probably staying in this field for the foreseeable future. There's so much research to be done in this area.
Right. I'm especially interested in natural language interfaces, especially because this can make our lives more efficient, more productive. You can imagine, for example, for NLI to databases or to computer programs, it can make your life much easier when you use such kind of technologies to write programs or to explore your data.
Got it. And we have one question that came in from the audience was around GPT-3. When OpenAI released that, what kind of impact do you see GPT-3 having on the industry, on the NLP kind of scene as a whole? Is it considered like a game changer, or are you thinking more about like an incremental to what already is out there?
I think that's a fantastic question. So I think it certainly has a huge impact on the research community and also probably the industry community as well. It has, very amazing performance on the generation tasks. For example, for the text-to-SQL or text-to-program application scenarios, you can throw in several examples and they will just generate similar programs or programs related to your natural language query. I think it's certainly, but I also, for the research side, I also think it's very important to understand why it is working that well and how do we further improve. And it is also important to build other more transparent models so that, or less, time consuming or less models that can be trained more efficiently. Because as a university lab in academia, most of the time you don't have so many computing resources to build those giant models or train those giant models. It takes a lot of time. So I think it's also important to explore alternatives that can perform maybe slightly worse, maybe competitively, but that can be more efficient and more explainable, transparent in terms of explaining the results to the users. This is also very important.
Yeah, that's a great point. I mean, I think the economics of running models is something that is sometimes hard to comprehend because you mentioned, I mean, there's GPUs that are involved in running these models. They could really get expensive. So something like that, I mean, especially with limited resources for like smaller companies or something like that, that could be interesting to explore. Along those same lines, kind of along that economics aspect, something that I really want to ask, because some of the viewers for the video, they're all from kind of different businesses. They're also thinking about when they're looking to explore the applications of NLP, like how should they think about quantifying the value for this technology? Is it about like saving time? Is it about getting more insights or something else? Like, how do they justify the economics?
Yeah, so that's a great question. And to be honest, I don't have much experience with doing business yet. And I'm interested in entrepreneurship, but I haven't got time for it. So my answer to this question will be, I guess, limited and biased. But I'll just, share my 2 cents here. So I think, like the value of the technology actually, to me, it boils down to how many users would like to use it, like it, and could live without it. So basically, how the users can benefit from the technology. I'll still use NLI as an example, natural language interface as an example, but I'm not saying like it is limited to this technology. So say here, if we can allow the user to use natural language to query, explore big amount of data, or to write computer programs, or at least assist them in writing programs so that they can program very much faster or more enjoyably, then it can save them a lot of time, tremendous of time. They can be more productive. They can focus on what they are better at. Or, like they can, for example, if you are a data scientist or you are a doctor, you can focus on formulating hypotheses, verifying this hypothesis without worrying too much about learning SQL or learning Ruby or Java or Python, this kind of programming languages. So it can save you a lot of time and let you focusing on, what you are good at and maybe more creative stuff that require years of expertise. So I think maybe this is one way to sort of quantify or look at the value of the technology. But I also think this is kind of, this maybe involve multiple factors. I feel like the time saving or making people's lives more productive might be one way to look at it.
That was a great answer. I mean, I think kind of like thinking about it from like a sort of like a human resource perspective of like, what are the skill sets and the upskill that we can provide to the existing team, the workforce that you have in the company, and how much do they like it? I think that's like how much like a change does it bring around in the work culture that you have. I think that's an interesting angle to look at it from. And kind of my last question to you is around like the area of NLP. There's so much happening here. Like what is an area within NLP that excites you the most, that you think can be like a game changer for the industry and for the world?
Yeah, I think for me, of course, my opinion is biased. I love the field of intelligent personal assistant or virtual assistant, where you can see natural language interface or dialogue systems play a key role there. So to me, I feel this can be a life-changing or culture-shifting field. Nowadays, personal computers, smartphones are everywhere. I would imagine one day everybody would have a personal assistant, so they can help you with a special task, maybe not every task, but for certain types of tasks, they are like your personal assistants, and they are there to help you save time and enjoy life better. Right now, if you interact with, of course, there are, commercial products like Google Home, Alexa, Siri. They're not, perfect yet, especially when it comes to complex tasks or complex questions. And I'm sure you are experience frustrations when you interact them, if you interact with them often enough. But anyway, so there has been a lot of active research in this space. I really hope one day that this area can be mature enough, and we'll have more successful products, and we enjoy working with our intelligent assistants, and our work, our life becomes more productive.
No, yeah, that's a great answer. I mean, I think that's our virtual assistants are kind of like everywhere now, right? I mean, like in the car, in our homes, and sometimes at work too. I mean, it's just kind of ubiquitous now. So yeah, I mean, I agree with you on that. I mean, I think that's going to be a fantastic area. I just like, there's, like you said, there's a lot of gaps still with even these massive companies, and hopefully, I mean, we can kind of slowly fill those gaps. I mean, and with your research too. I mean, this is very exciting.
Yeah.
But thank you so much, Dr. Huan. It was excellent to have you, and thank you so much for talking to all of us today. Thank you, AI Texas Group, for attending this webinar. We'll have a lot more of such events coming together in the next few months, so keep a lookout for that. But thank you so much again, Dr. Huan. Thanks for having us.
Thank you, Sid, and thank you, everybody.
Thank you.
Have a good weekend. Bye.